Okay, this is from a calculus exam, an Italian calculus exam. Verbatim, it said this over here, which reading it, certainly I don't read Italian, but it says calculate that sum, and it's not an easy sum to do. There are some trivial cases, but for the most part, they want a closed form of that sum, all right? Now, you don't need calculus to do this. What I would normally do is just write down what the sum looks like, all right? I do notice there's an error over here. I'll correct this. You're not going to see that. That should read nx, all right? It's going up to n, all right? Now, I just want to do a little review of what you've done in Math 120. And certainly Math 100, you said a complex number z was a plus bi. Then when you got to Math 120, your teachers told you about, this real axis and this imaginary. And then they said that any number in that form, a plus bi, could be a coordinate pair. And there'd be a line over here, a segment. That was r. That's the distance from the origin to that point. And so the r would be equal to the root of a squared plus b squared. Maybe I should emphasize that a and b are any real number. There'd be an angle theta over here. And then they said you could rewrite this, z number as a. And what would a be? A would be r times the cosine of theta. And what's the b going to be? Well, that's going to be r sine theta. And we got an I over there. And that's that famous form you got in Math 120, that z was equal to r cosine theta plus I sine theta. This could also be written as, z equals a plus bi. This could also be written as, hopefully your teacher in Math 120 also talked about another form of it, which was r e to the I theta. All right? All three forms are good. All right? Now, certainly, we're trying to plow forward. This was why even bothering, just reviewing what we've done in Math 120. All right? So what I want to do is I want to write down, r e to the I theta is r cosine theta plus I sine theta. Divide both sides by r. Provided r is not 0, that's fine. And you would get cosine theta plus I sine theta. All right, pretty interesting concept over there. And next thing I'm going to do is write down e to the minus I theta. This would give you a cosine of minus theta plus I sine minus theta. I'm just replacing the theta with minus theta. And even identities, that would give me e to the minus I theta would equal, let's see, cosine theta, even identity, minus I sine theta. All right, let me write down right next to it, e to the I theta is cosine theta plus I sine theta. Well, a couple of things you could do here. Just add them together. And what would you get? E to the I theta plus e to the minus I theta would be equal to 2 cosine theta. So e to the I theta plus e to the minus I theta over 2 is cosine theta. All right? Now, that's kind of an important result over here. I'm going to put a little box in this over here. And the other one I want to do is just subtract them. And if you did that, I'm going to put down e to the I theta minus e to the minus I theta would be equal, the cosines would disappear, and you would get 2I sine theta. And so I'm pretty comfortable with that too. I'd get, e to the I theta plus, I'm sorry, not plus. Get my eraser out. Minus e to the minus I theta over 2I would be the same thing as the sine of theta. Put a little box in that. All right? I'm going to outline where this is written for you. And this is written over here. All right? And I say that's what I got written over there. And the only thing I really did was I rewrote the sign. And not using theta, I used kx. So I just replaced the theta with kx. Not much of a difference over there. All right? I want to get my eraser out, though. And by erasing things, I do see that written down, but I don't see that cosine written down yet. I'm not going to erase that. I'm going to erase this business over here. All that work getting there, I'm erasing that. And I do need to move forward. All right, so I got something. I got a milestone in my notes. Let me erase this business up here, too. I'm kind of done with all that stuff over there. all right? So I just want to take that sum, which is what they want me to do, this thing over here, and instead of writing down, sine kx, I'm just going to put that new form of it over there. And by doing that, I factor out the constant, 1 over 2i, and I break it into two sums. All right? The next thing I did, which may seem unusual to you, I start to recognize it looks sort of geometric to me. And I put this over here. I write the geometric forms down. Let me just remind you, the geometric, and let me write this over here. Same form, k equals 1 to n, and I'll put down a to the k. What would this equal to? This would be a plus a squared, yada, 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 all the way up to a to the n. And I'm going to say Sn now is a plus a squared plus yada, 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 up to an. And just like you did in Math 120, multiply both sides by a. Now, there are problems here, but let's not worry so much about that. And I said those problems are just trivial cases, by the way. A squared plus yada, yada, yada. You'd eventually get to an, and then you have one additional term, n plus 1. I'm going to subtract. What would you get? 1 minus a, Sn, and then you get a minus a to the n plus 1. So Sn, really what we're looking for, would be a minus a, n plus 1 over 1 minus a. And your teachers in Math 120 probably factored the a out from the top. And they would get 1 minus a to the n over 1 minus a. That's probably the most famous form over there. So you could rewrite these sums now, and pretty easily, by the way, and using that geometric. There is a problem, like if, for example, if a were 1, I couldn't do that. But I'm not worried about it. They're trivial cases, by the way. The sum becomes very easy if that a were 1, by the way. So what I want to do is, I just want to look at those two sums separately. And I'll point out what I mean by that. We want to do this one and this one separately. And they're really easy to write down now, because we know that form, right? What's it going to be? Well, in this first case over here, e to the ix, and then 1 minus that e to the ix raised to the n power, and then 1 minus e to the ix. And the other one's also easy to write down. All right, the a is e to the minus ix, and this is going to be 1 minus that thing, e to the minus x raised to the n, yada, yada, yada. So I have something pretty simple, all right, that this sum now can be written like this, all right? And the next thing I want to do is just, kind of talk about that these, I'm not saying they're recognizable at this point, they're not. Right? I don't have that much experience to saying things are recognizable. Even if I have experience, I kind of lose it over time, by the way. And you start to use local memory. But I'm kind of looking at this thing, and I realize that we've talked about this before. All right? And we talked about this before. Whoops, I see a mistake over here. So the I over here has got to be crossed off. Right? There's no I over there. So really it's just e to the ix over 2 plus e to the minus ix over 2 over 2. Sorry about that. All right. All right. We did that before, by the way. What I mean by that, just replacing the theta with x over 2. All right. Let's talk about this guy. We just did that. Plug in x over 2, I get this over here. And, cosine theta, again, I see the I again. I got to cross that off. So this over here is not there. All right. We did that before, by the way. I got these guys over here. So what I'm going to do now is look at those things and try to find those things. So again, we're looking at this. I want to try to find these things in that. Right? So the first thing I did was I distribute this across the top in both cases. Now you get this in the bottom, that in the bottom there. Let's distribute the top. Well, pretty simple. First guy. What's next guy going to be? Let's see, e to the ix plus I and x. Well, that's pretty simple. Over here, also pretty simple. All right, just distributing, all I'm doing. All right. The next thing I do, which is more complicated, is I'm trying to see those things, by the way. Someone says, what things are you trying to see? I am trying to see these things over here. I'm trying to see them. All right, I'm trying to see them. And some things are easier to see than the others. So what I do is I factor this out from the top. And if you do that, you get this on top, and you get this on bottom, right? And then what I notice about this, I notice that these things cancel off. So I'm left with this now. And then I'm seeing the bottom being related to this guy over here. And really it's just 2i times the sine of x over 2. Or, I'm sorry, minus 2i times x over 2. I get this over here. The top's killing me, though. I'm not sure if I recognize that. What I did was I kind of multiplied top and bottom by minus 1. Relatively simple. I get this over here. Well, let's do the other one. Let's do that second term. And again, the second term we're talking about is this guy over here. What do I do over there? I factor out e to the minus ix over 2 from top and bottom. Relatively simple. You get this on top and bottom. Rules of exponents, by what does I mean by simple? I get this on bottom, because these are going to cancel off now. Top's killing me still, looking at it. Whoops. But the bottom I recognize. All right, the bottom I definitely recognize. And what do I recognize? It's just simply 2i sine of x over 2. And where's that written? That's this thing up here. You've seen that before. All right, you've seen it. Then what do? I just write it down. I rewrite the sum as this. I'm going to multiply the bottom out, though. And what do you get? You get 4i squared, which is actually minus 4. So I pull the minus on the outside, and I get this on the bottom. And what do you get on top? I get this, I get this, I'm subtracting this, and I'm subtracting that, which is going to be plus that now. So I'm sort of at a stage now where that top is still killing me. But what I want to do is I want to associate things together. Like, for example, I believe these two things belong together, so I put them together. And I believe these two things belong together, so I put them together. All right? Then the question is, do you recognize them? Sort of. I kind of recognize them. And what I mean by that, looking at things, I kind of see this over here, right? Recognizing that to be related to that cosine problem. Recognize that it's over here, so it's just going to be 2 cosine. That's all it is. Right, I got this written over here. Okay? And then the other one's also recognizable. To this guy over here, also recognizable. From that identity. What's it recognizable as? This thing over here. All right? So we have a closed form now. All right? All I'm going to do is distribute the minus sign across it, and we get something. Also, I divide through by 2. I get this over here. I'm going to say this to me is the final closed form of it. All right? And by the way, there are some problems with this. This was k equals 1 to n sine kx. All right? However, I'm starting to realize I might be able to do something else. Don't feel obligated to do so. I'm looking at this, a sum or difference to product formula. And what am I seeing over here? I'll write this down for you. I'm seeing the cosine x over 2 minus the cosine of n plus 1/2 of an x equals 2. A minus b is x over 2. I'm just making a comparison, by the way. And a plus b is equal to nx plus 1/2 of an x. I'm going to add those together. And what would you get? You would get 2a. Let's see. You would get nx. Well, half an x plus half is just an x. So what do I get over here? A is equal to n plus 1 over 2x. All right? Not so bad, right? I got this over here. I got the A. I want to show you where that's written, by the way. That's written right over here. That's nx plus x over 2. Let's do the other one. Let's get the B. All right? So let's write this down. I'm going to use this over here to figure out what the B is. So A is n plus 1 over 2x minus B equals x over 2. And let's write this down. This would be nx plus x over 2 minus x over 2 is equal to B. We're trying to figure out the B, right? And you're just going to get nx over 2 now, all right? And where's that written? That's what B is, by the way. The B is nx over 2. Where's that written? Right over here, all right? We get everything written down. And the 2's cancel. Yeah, things are fine. I'm going to say this is a better form. It's better than this one over here, but they're both close formed. Thank you for paying attention, though. I do want to point out this, in my opinion, is an extremely difficult problem. Although this appeared in a calculus exam in Italy, my suspicion it was a take-home exam. The problem with take-home exams nowadays is you could easily go to the internet and find a solution very quickly. Just go to YouTube and you can find, probably dozens of people did this problem over here. Is it always going to be the same way? No, it's not going to be the same. But this is not a bad way of doing the problem, all right? Again, my name is Ron Bannon. If you need to reach out to me, my email address is Bannon, that's B as in boy, the @ NNON.US. Thank you so much for paying attention.